Hello, everybody, once again. Today, I'd like to share the latest updates from the RGB development progress and also some more long-term vision to jointly technical part and non-technical vision, how we see these components, RGB Lightning Network and other parts of LNPBP stack and protocols working together. I had some sort of vacation for the previous weeks. I wouldn't say that I was going to the vacation. I was a bit ill, and then I was just too tired of high tempos of the development that I had before. So I was doing stuff in more relaxed way. And overall, over the time, also the one thing happened that we understood clearly that to complete the RGB protocol and stuff we are doing in LNPBP association, we can't how to say that, we can't anticipate any external funding. So everything that we are doing from my own funds and my business and my colleagues' funds who are present here, Olga and Sabina. And we basically want to do that and continue that effort as long as it takes and as long as it is required to complete this story. And because we are not even now waiting for any funds from anybody, we are more free in selecting the tempos and the speed of the development. So I have reshaped a bit a roadmap for the future development. And overall, I'd like to follow the approach that it's ready when it's ready. Because I was frequently trying to explain that with the client-side validation and things like RGB, we don't have ability to modify the protocol after the release. Once it is being started used on main chain by some large issuers, doing assets that other people use, or other forms of smart contracts, there is no way back, because basically there are certain forms of possible upgrades, but it's very complicated coordination. It will require very complicated coordination, and it will dramatically reduce the public interest in the protocol if it will be too early stage. So the approach that I was doing over the past year and more than a year was that actually I'm starting building by layers, the whole protocol by layers, and I'm coming from the lowest level to the up, until we reach the stage of the consumer-facing products, which we also do by ourselves, not as a part of association. There are products from my company and business, but the whole protocol stack and everything that is related to infrastructure is a part of association. It's not non-profit. But anyway, the idea is that I'm building from infrastructure till the products, and when I see that at the user level something is not working, I'm going back and restart the whole cycle. So up to today, we had 4 complete cycles. Before that, we had complete rewrites, but after we have the final rewrite, we did 4 cycles on improving the protocol. And when we come to the end user-facing applications, we see that something is missing. For the proper user experience, we are going back and designing something underneath at the lower protocol levels. And it was only on the 4th cycle when we were able to produce first working wallet with RGB called MyCitadel, and a few other tools like Bitcoin Pro for asset issuance. We were able to do that on the 1st cycle, and we also did a small prototype of RGB Explorer. So we got a lot of feedback, especially from MyCitadel wallet, and we also understood a few significant drawbacks which may prevent the real RGB adoption. Like when you are sending the payment, you need to send the consignment using some messenger or something, and some more automatic ways will be required. The importance of the backups from the very beginning of the protocol, and so on and so forth. Also, we draw a lot of experience from working with a Lightning Network, and I will have a dedicated section today in the presentation of what we understood about Lightning Network, how we are embedding RGB into Lightning Network, and what it will take to analyze this process. Concluding this part. So after the four cycles, right now we're in the middle of the 5th cycle, and I expect this will be the last cycle before the mainnet release. I mean, before they're doing some assets on the mainnet. So with this cycle, I plan to finalize the first versions of my Citadel and other client-facing applications, as well as the nodes and everything related to the infrastructure that potentially can be used by the crazy people on the mainnet. If you're going to lose funds, you will be able to use that. But more importantly, and setting jokes aside, it's not about mainnet and real assets as more about freeze of the protocol, freeze of the APIs, freeze of the standards, and the only thing that will be changed after that will be a bug fixing. And with this cycle, also the plan is that it will be completed layer by layer, and on each layer, I complete work on the code, so it should be written the best way possible. On the code documentation, it should be 100% covered by the doc comments on the test coverage, and writing up the standards related to this part of the code, or finalizing those standards. So it's all prepared for audit. And it is happening layer by layer. And I will be spending most of the presentation explaining what are those layers. So this 5th cycle will take longer, probably, than previous cycles. We will also finalize the Lightning part during this cycle. And another very important point is that I'd like to see Taproot fully implemented. So the version which we will have as the result of this cycle, like my Citadel, the RGB Lightning Network, and consumer-facing applications like my Citadel wallet, they will not just support RGB, they will support Taproot. Of course, until the activation, final activation, which may happen in November, it will be supported only on Signet. But the idea that once activation will happen on the mainnet, there will be nothing to change or update. So fingers crossed, but probably we will have the first Taproot-enabled wallet during this summer, also supporting Lightning Network and RGB. But I don't know. I can't promise, because it will be ready when it is ready. So the roadmap, I'm not putting any dates here because I have no idea. It will be completed as it is completed. The layers that we have to complete with RGB starts with the client-side validation, which is even not RGB directly specific. It is used by RGB, but I will explain how it is more generic comparing to RGB. So the client-side validation is the layer I'm completing these days. It's already 100% code documentation covered and mostly test covered. And I expect that during the next week or so, it will be published and finalized together with the last standards. Also, I'd like to draw your attention. There was very interesting discovery. There were a few people who were reviewing the standards we have related to this client-side validation part, and they found few improvements that can be put there. For instance, we haven't specified the exact key serialization format for preparing each MAC, and we can serialize it in a more efficient way. So you're welcome to join that discussions in the LNPBP standards repository. There are issues and pull requests, and it's all happening there. So you're welcome, and that is the part of the finalization process. So you're welcome to be in this part. After that, I'm already working a lot on bringing Bitcoin Taproot to Rust Bitcoin and to the ecosystem around it. It will take quite long, especially because pull requests are taking a long time to be reviewed in the Rust Bitcoin, but probably I will maintain the specific fork supporting Taproot earlier than it will be adopted by the mainstream Bitcoin, Rust Bitcoin, just to get it working in our products. After that, we will move to completion of the single-use seal and commitments related to Bitcoin, then RGB core library, then RGB standard library, which differs from core. It's again another new separation of layers, coming from the fact that RGB core library is basically covers very basic standard functionality without a lot of external dependencies. RGB standard library, it's more a tool for those who would like to develop custom schemata and do something a new schema type, but they don't want to deal with the low-level APIs of RGB. So we will have this layer that simplifies the custom schema development. On top of that, there is a progress about virtual machine. We were expecting to use simplicity for RGB, and we were really keen to see simplicity there. Unfortunately, it seems that simplicity development is frozen. At least it's not happening for at least last half a year, and it looks like it will take more than a year to get something working in Liquid. So we wouldn't be able to have simplicity in the first version. We will probably reserve it for distant future RGB second version, which will be incompatible with the first one. So we have to replace virtual machine with something, and we already had a discussion of that topic on one of our calls. And we did a discovery, we did a research, which virtual machines are available, what are the trade-offs, and it came out that the best way forward is to have a virtual machine. Well, it wouldn't be a very complex virtual machine. It's not like something VM style. The concept of this virtual machine is pure functional, meaning that it can't fail, it can't produce exception, it is non-stack but registry-based. Anyway, those who are interested, probably I wouldn't spend more time on that today. You are welcome to the video recording of the call where we were discussing that, and I was presenting that part. So the virtual machine has to be completed, not the language for smart contracts, but the low-level bytecode virtual machine has to be completed. It's not a big deal since the code is already written. It's more like separating this part of the code into more isolated environment and calling that virtual machine, and formalizing this part with a standard. After that, we will be finalizing schema. Right now, we have 5 schema defined. And if you check the repository, you will see most of them are very close to the completion. This was the topic I was mostly focusing in the March and early April this year. Specifically for RGB20, we now have a second reissuance, we have a burn and replacement, we have elimination, we have developed a rich API to cover all this functionality. We have found a way how to publish and distribute information, not just about the primary asset issue, but when you do a second reissue or burn and replacement operations, you will be also able to deliver that information to the asset owners and users. So that is mostly done, but anyway, it will be finalized after the previous layers that I covered. And after that, we will work on integration of all this stuff into our products. And of course, as a part, it's actually part of our product line, we will provide an integration kits to get one-place integration points, like you integrate just a single library called Citadel Runtime, and you got RGB, Lightning Network, Taproot, Miniscript, multi-sig wallets, all of that using in the same, working in the same thing. So you can basically embed that into your wallet applications or use that for server-side integrations. Partially in parallel with that, there will be developments related to Lightning Network. First of all, we have to make Lightning Network, Miniscript, and Taproot compatible. It's not just a LNPBP effort. There are many other people and contributors who are interested in doing that, and I already talk to a few of them. So we will join our forces, because basically the version of RGB that will be used in a Lightning Network, because RGB I will be briefly describing later, RGB requires anyway modification of the Lightning channel transaction structure, because we're doing tweaks to the public keys, and we can't make a channel between RGB enabled channel when one of the nodes is not RGB enabled. It's impossible, not just technically but logically impossible. So we are modifying the format of the transaction anyway, and this is why it makes sense to use for RGB only Taproot and Miniscript based version of the Lightning Network transactions, or the state channel transactions, because we will have to update anyway, so it's better to do it from the very beginning and just not support the legacy format. So that's also planned. Next point is that we will finalize the LNP library and node to the level that it will work with the rest of the Lightning Network with Bitcoin, full 100% Bitcoin compatible functionality. We will finalize RGB related parts of the messaging and feature set. Also, we'll be covering on the future slides. And we add that to Citadel runtime. And finally, a brief roast, which I will be talking later, and I will mention this part of the roadmap later, so I will just move forward. Now, the next part, probably maybe let's do a question and answer section after each session, So if you have any questions or comments, let's discuss them, and I will move forward.
Any questions for now, guys?
Yeah, can you guys hear me okay? This is Max.
Okay.
Yes, go ahead, Max.
Yeah, just a brief question. I don't want to take it off topic or anything, but either for Maxim or for Olga, what would be the next step in the process to assist you guys in getting this on Lightning? Are we, again, what we discussed before, are we essentially waiting for kind of Taproot activation, or what would be the best first initial step where you guys need help to get this over into the Lightning first?
There are a few things that can be done today. Of course, we will not wait for Taproot activation. Everything that we need is already there. Taproot code is finalized in Bitcoin Core. It's just the question of turning it on. And we already have a Signet network, Signet testnet in Bitcoin, where Taproot is already activated. So we can use that, and we are not prevented by anything. But in terms of help, there are areas which we really, really need help, and where the help can be delivered in an efficient way. And these areas are areas of common interests outside of our own activities, like finalization of Taproot implementation in Rust Bitcoin. And we will be happy to join forces with other people, and you don't even need to coordinate with us because it's an independent project. The same applies to Lightning Network. We really need to bring Miniscript and Taproot support into the Lightning Network, and there is nobody who is championing that today. I was discussing this question with Christian Decker. I was meeting him last week, and he said that everybody is interested, nobody is working on that. And basically, we need more hands who can write the proposal to the bold specification of how specifically Miniscript and Taproot can be implemented. So it's not even about writing the code; it's more about writing or modifying existing standards. The third part where we need help.
Sorry, Maxim, may I interrupt you? May I interrupt you 1 second about this? So
sure.
In this case, you're talking about how to, let's simplify like that. We're talking about a standard to describe a Lightning channel using Miniscript and descriptors. So is that right?
Well, it's not even a standard. It's basically a pull request to existing standard adding a paragraphs to each transaction output description, saying that if we use a mini-script feature flag, the actual script should look like that, and that's all. So it's very
Okay, thanks.
like pinpointed modifications. With a taproot, it's a bit more complex because we will probably need to modify a format for different Lightning Network related messages. But basically, it narrows down to pretty much the same thing. And I was even thinking about that these two things should be done together. So we should use miniscript to describe a tap script, embed it into a taproot, and do that as a single package of changes. So with a single feature flag. So that's
Nice.
my idea. But of course, even if I will write this proposal, which I'm not sure that I will have time for, so I will be happy if somebody else writes, but it seems that nobody is working on that. This proposal will need a lot of reviewers and support from the community. Otherwise, it will take forever to merge it into the bolt, because again, it happens that it takes more than half of year to merge there even a simple things, and the stuff is ending these days that like in C Lightning they're just implementing something like dually funded channels, then they write a standard, and then in C Lightning today you have dually funded channels, but the standard even is not being discussed by the Lightning community yet. It is written, but nobody is discussing, or there is little progress on merging it. So basically, I'm afraid that we will end up with the same thing. But anyway, we need this write-up to be completed in order to implement it by ourselves, even if it wouldn't be a part of the official bolt specification in the next half of the year.
Great, thank you for that answer. Thank you.
In terms of RGB, help with the RGB, I will be going with a description of the overall structure, and I will be pinpointing specific parts where help can be useful. The first thing is we need a reviewers to LNPBP 1 to 4 standards, and those who are willing to look into the implementation in the Rust code of these standards. It's very well documented, like there is more code documentation than the code itself. And making sure that nothing is missed, everything is done as it is written, and so on and so forth. Because this client-side validation layer is the security and consensus critical. It's the most security, double spending prevention, and consensus critical. If we will do everything correct here, we wouldn't be able to double spend, basically. The next security critical layer will be RGB core library, especially schema implementation and virtual machine implementation, which are already written, but I'm not inviting for audit it yet, because I would like to go once again myself, complete the whole test coverage and documentation, and write the standard about them, because it's not written yet. And after that, I will be inviting reviewers and those who are willing to do audit. We don't have funds to pay anybody for the audit, but if you have resources, time, and desire, you are welcome. You will be welcome to do that there.
Great, thank you for the answer for the questions. That really helps. We can continue on. Thank you.
Thank you. So I will move on. Oh, there is somebody else who would like to ask something. I was hearing somebody unmuting, probably was going to talk. Anyway, you're welcome to interrupt me. Yeah, go on.
No, that was just a message sent to the chat. That's okay.
Ah, okay.
Mm-hmm.
So let's move to client-side validation. I wouldn't go into all the technical details at all today. We have already 2 deep technical talks covering them down, narrowing down to very low-level things. So you can just watch the previous videos on the YouTube channel of LNPBP Association and read slides from the GitHub. Olga will share the link. I will do a very high-level overview of what it is. what is client-side validation stack is and how it is related to RGB. So describing RGB smart contract stack, we need to see that client-side validation is the lowest level of it. And this level, when we're saying client-side validation, it's something more generic than Bitcoin. So there is an application of client-side validation for Bitcoin. But basically, you can apply the client-side validation concept to Monero or to any other blockchain if you need to. I don't think that you need to, but theoretically speaking, client-side validation is a paradigm of the computer science that defines how you can build a distributed system without maintaining the shared state and without validating the shared state, but using some proof of publication layer or commitment medium, we call it also commitment medium or commitment layer, which in our case, in case of RGB, is Bitcoin transaction graph, which I laid up on top of the client-side validation. And when I'm saying Bitcoin transaction graph, it doesn't mean that it should be Bitcoin blockchain. It could be any transaction graph. The only question is up to you as a client-side validating party. You have to define which transaction graph, Bitcoin transaction graph, is valid for you. And probably you will trust Bitcoin blockchain, mine transactions, and probably you will trust a transaction graph inside the channels that you have and that you manage by yourself with your private keys. And this becomes a Bitcoin commitment layer for RGB that you use in client-side validation. So the first blue layer is basically a generic APIs which are not linked to Bitcoin, any Bitcoin library, which have no dependency on Bitcoin transaction structure. They're just expressing everything needed in client-side validation before Bitcoin. Then there is a layer on top of that using all of that code and APIs, which we call Bitcoin-based client-side validation. And this layer actually implements whole paradigm of client-side validation for Bitcoin transactions. And this is not RGB yet, because with these two layers, you can do other things than RGB. There are multiple theoretical examples and even one more or less practical. I wrote a mail in February to Bitcoin developers mailing list describing how you can use Bitcoin single-use seals, which is a part of Bitcoin client-side validation, to construct Bitcoin publicly based identities with wallets. And it has no relation to RGB. It's a different application of this stuff. That's why we are keeping all these layers as a separate libraries so they can be reused outside of RGB scope for other purposes. And only on top of that, we are building a client-side validated smart contracts, which is actually RGB. So this is a specific application of Bitcoin-based client-side validation. Digging a little bit more into each of these layers, for the first blue layer, I would say that there are three main components called strict encoding, the component related to cryptographic commitments, and component related to single-use seals. They are independent from each other. And if you will go, I will just switch the screen. Oh, how to do that? Yeah. If I will go into the code, I welcome all of you. Today I just published, so we had a Rust LNPBP library, which originally was a library that contains everything. And with the development is being split into more and more libraries. And just yesterday and today, I extracted the client-side validation into a separate library. And this library includes both non-Bitcoin and Bitcoin-specific parts. There is a description describing these components and a clear separation about non-Bitcoin specific part and Bitcoin-specific part with the links to the standards. And if you dig into the code, for instance, if I will go into commit verify or better single-use seals, here. You will see there is a lot of documentation describing the whole API, how it works, why it works this way, and basically I will use this documentation to write up the single-use seal standard as LNPBP standard. So you're welcome to audit this part, and the rest of this library is mostly completed in terms of documenting and API freeze. And there is a specific Bitcoin applications like deterministic Bitcoin commitments and Bitcoin-based single-use seals, which I will be talking in the moment. So these three components are, first, strict encoding is the way how you can encode the data in the most deterministic and predictable way, suited for client-side validation specifically. It's a standard, and it's a reference implementation of that standard. In this standard, we are limiting such things like you can't have any piece of data larger than 64,000 of items, basically 16-bit digit integer. You can't have a string longer than 64 kilobytes. You can't have an array with more elements than 64,000. And this allows you to build a very deterministic computing, actually being sure that you are always able to feed all the required data into the memory, do the validation, even on low-level hardware or specific dedicated devices. And many more things, making this commitment and verifications deterministic, so strict encoding. The second block is actual commitments, how we can commit and verify commitments at the client level site in general form. We define the general API of what is commitment, what is verification of commitment. We define how we modify specific encodings when we need to do a partial commitments. For instance, you have a list of state transitions and you would like to reveal just some of them. So you have to Merkleize them and commit to the Merkle tree root. So that is slightly different from strict encoding when you just linearly serialize all the data. Here you create a Merkle trees, and how these Merkle trees are constructed and everything like that is covered in this part of the library, commit encoding, and consensus commitments, which are based on these two things. Finally, there is important piece called multi-message commitments or multi-commitments. These are a standard called LNPBP4 of how you can combine different data pieces in a very hiding way and still create a single deterministic commitment, which you can use later, and you can disclose only parts of this data and still be able to prove certain statements about those data. And again, you see it's very generic. It's not specific even to Bitcoin transactions. It's just standard that can be used in many different aspects. So these are also implemented in this library. And finally, single-use seals, which may work not even with Bitcoin. So the current single-use seal implementation on the lowest level is basically defines the concept of what is seal, what can be done with that, how it can be verified, and basically it's a programmed implementation of the Peter taught single-use seal concept. In the next layer, we are moving to the Bitcoin client-side validation, and here I show how we actually apply those abstract concepts to specific Bitcoin transaction graph. There are two main components of Bitcoin-specific part. The first one is deterministic Bitcoin commitments. They define how we can use different parts of Bitcoin ecosystem to create commitments to some client-validated data. And these parts are elliptic curve-based commitments. You can use a key or a set of keys to create a commitment, and this is described by LNPBP1 standard. Then there are script-based commitments, how you can make sure that you use particular Bitcoin script or top script to do deterministic commitments in LNPBP2 standard, and then how you can embed that into transaction outputs or even transaction inputs, which is also possible with assigned to contract commitments, and then transaction-based commitments, how it can be put all together. The next block is Bitcoin-specific single-use seals. And currently, I have to say that there are at least 3 ways which I know how single-use seals can be implemented for Bitcoin. We are using one way, which we call UTXO-based pay-to-contract single-use seal, and it is used in RGB. But the library also will define the sign to contract, transaction input based single-use seals, which we will probably use in this future version or second version of RGB. And we haven't implemented, but generally I can think about stuff like address-based variants of single-use seals and so on and so forth. So if anybody needs, you're welcome to do the PRs. And finally, only on top of that, we are building RGB, which are client-side validated smart contracts. And the contract, RGB smart contract, is basically consists of three main blocks. The first is a state history in form of directed acyclic graph. Like Bitcoin transactions history is a graph. Here we have another graph, which we called RGB state history graph. We have RGB schema, which defines the rule how this graph history can be validated and must be validated. And also, schema may contain RGB scripts for a very specific and custom validation logic, which will be executed on the special dedicated virtual machine, which we call ALUVM. Basically, it's arithmetic logical unit virtual machine. And all of these three compose RGB smart contracts. So, in general, if we will look data-wise on the RGB, on the client-side validation from the level of RGB, we will see the following way. We have, we'll go out to presentation mode. Do you see my mouse? So I can point it.
Yes.
No.
Yes.
Yeah.
So here on this level, we have basically the core data structure. There are data structure presenting the smart contract, genesis, state transition, and state extensions. They are basically forming this RGB state history I was talking about on the previous slide. Genesis is one per contract. It's where the contract starts, and it is always created by a contract issuer. State transitions are changes in the state which are committed to Bitcoin blockchain. Basically, when you do a state transition, you have to be owner of some part of the state, and you have to create a Bitcoin transaction. And there is one thing that we call state extensions, which is state changes which are not committed to Bitcoin blockchain. And this allows you to construct more wider and broader participation in the smart contract, such that parties which do not have any assets or anything, they still can execute some forms of smart contract logic. And while in RGB20 assets, we are not using state extensions, they are extensively used in such things as, for instance, decentralizedly issued coins. You can build, for instance, Bitcoin-backed RGB Bitcoin representation, or even use the Tether representation, and you will need state extensions to that to do that. And also, they are very extensively used in things like decentralized naming schemas and identity management and reputation schemas. So I've been already covering that in previous presentation. Especially, I invite you to look at the presentation where I was talking about the identity, naming, and reputation. Here was the presentation I was giving a few weeks ago. So you're welcome to find it and see it. So these are a single smart contract and the state history of that smart contract. In addition to that, there are schemata, which is a plural form of schema. This schemata cover multiple smart contracts, but independently. So basically, each smart contract has a schema, which defines the rules of validation and which is executed on a virtual machine together with scripts it contains. And the third thing are anchors, which is an important part of the story. It is not part of the smart contract. The anchors basically connect multiple smart contracts in a hiding way to Bitcoin blockchain. And it allows you to link many state transitions to a single Bitcoin transaction output. So while they are not part of a smart contract, you have to commit to the anchor data. So here I define the part which you're committing to, and they are part of the stuff that is validated on the client side. So all of these smart contract history graph, schema, and anchors are client-side validated data, which can be packed and represented by 3 data structures. Containers, we name that. The first container is a stash, and the stash is a user-specific local copy of all your smart contracts. So stash contains all your smart contracts together with schemata and the most detailed information that you can have. But you don't share a stash, you can only backup it. Consignment is a container that consists of a single smart contract, always starting from Genesis, and some part of its state history. You don't need to put all the smart contracts state history there. You put the part of the history that is related to specific situations. So for instance, consignments are used during the payments. When you send funds to somebody, you present the information about the funds as a consignment. But it's not only the only case. The other case is that if you are set issuer and you do secondary issuance of asset or burn and replace information, you publish information about this issuance to the network in form of consignment, which contains information about the issuer, not about the transfer. So these are consignments. And the third form is disclosures. Disclosures different from consignments by the fact that consignments always have a single smart contract starting from Genesis. Disclosures may be related to multiple smart contracts, and they're not required to contain a connected graph. It can contain random state transition without Genesis blocks, and you use disclosures to disclose some information which is confidential for you, but you want to disclose information to a certain party, you use disclosure for that. For instance, companies may use disclosures to disclose information about them complying with something if they need that. So all of these red blocks are client-side validated data. So you validate those data on the client side. Additionally to that, there is client-side non-validated data. You're not validating them. And we introduced them only recently. It's not even fully implemented yet. We call them data containers. And data containers are used to deliver information which may be related to the smart contract, but not necessarily part of it. For instance, if you do NFT, you use data containers to store image, song, video, whatever. You can build, for instance, they can be used if you use RGB to build a decentralized GitHub-like workflow with a pull requests, you will use data containers to store GitHub, to store Git repository, and so on and so forth. You are committing to the hash of the container to content, but the presence of the data is not required to do the client-side validation. So basically, and the containers may be related to multiple smart contracts. So I can issue a single song and create different smart contracts which are related to the song in form of different NFTs. And this smart contract will manage the rights of access to that data container. And these data containers are distributed and accessed through the same data distribution network that is used by RGB, which is Lightning Network extension called Bifrost. I will be talking about that in a moment, not in a moment, but a little bit later. So that's all about the client-side validation and RGB coverage. And the next section will be Lightning Network in RGB and more generic, even more generic LNPBP context. But before that, if there are any questions, I will be happy to answer them.
I have an organizational question. How many slides is left?
Like we're on the middle of the presentation.
I think it would be good for me to restart the video after this current Q&A session.
Oh, this is the last session, section. But
yes,
okay,
I know, but it's already 45 minutes of the video, and yeah.
I think I will need about 20 more minutes. So do you need to restart it now?
No, after the Q&A session.
Okay.
So there is a question. There is a question. The anchors will be used in DEX functionality, right?
No, they are used in the core RGB functionality already, and they are of little use because, well, they are of very important use, but very specific and narrow use. You can basically use them to link multiple smart contracts to the same, multiple state transitions to the same Bitcoin transaction. It's a scalability solution, let's say like that.